Now let's go over how we get this answer on this one. So we got 3 rectangles on this and then 2 triangles. The triangles are the same size, which is why there's a prism. But we'll notice, I'm going to start with the triangle right here, that they actually gave us the lengths of all 3 sides of the triangle. Not that that matters. But they did give us that this is the right angle right here at the bottom. So right there, okay? So while we do know that this longest side here is 10 kilometers, or kilometers, whatever, the only part that we really care about is the base and the height, which should create a 90-degree angle somewhere, and it showed the 90-degree angle here, okay? So while it did show us 10 kilometers, we don't really need that. To find the area of that one triangle, we would take the base at 8 and the height at 6, multiply those, but divide it by 2, which is 24 square kilometers. But there's 2 of those, so I'm going to multiply that by 2 to get 48 kilometers from both triangles, Then we look and we got 3 rectangles. So I'm going to start with this front one right here on the front left. And so if I were to redraw that, I'd have 8 kilometers here. And we're just looking at the height there, which shows at 4 kilometers right there. So the area of this one is 8 by 4 rectangle, which is 32 square kilometers. And then we have this one on the right here. And those dimensions are pretty well defined at 4 kilometers by 6 kilometers. So this area would be 4 times 6 or 6 times 4, which is 24 square kilometers. And then we got that rectangle in the back right here, which is 10 by 4. So I kind of ran out of space here. Let's see, I'll do it up here. 10 kilometers by 4 kilometers. So this area would be 10 times 4, which is 40 square kilometers. So we got all 5 areas. We're only going to show 4 though because we did the triangle twice. So the 2 triangles were 48 square kilometers. We had the green rectangle at 32 square kilometers. The red rectangle at 24 square kilometers. And the orange rectangle at 40 square kilometers. So we're just going to add these together. And this will be the total surface area of the figure. Oh, I guess we should find the lateral surface area too. Well, I already got the setup for total surface area. So let's do that first. 8, 2 is 10, there's 14, carry the 1, 7, 8, 10, 14. 144 square kilometers, which is what they showed right here. So that would be the total surface area, but they wanted the lateral surface area as well. So in that case, we're just looking at the rectangles, which was 32 in green, the 24 in red, and the 40 in orange. You could have just subtracted the 48 from 144, but it doesn't matter. So there's a 6, 5, 9, 96 square kilometers. That's the lateral surface area. And we already found the total surface area. Today's objective, I can find the surface area of cones. So there's our surface area of cone formula. And we'll explain what those are. You already know what the R is, but that L is a little different, okay? So take 30 seconds and copy this down with the formula. You're going to want that formula too. 30 seconds, go. All right, just as a little background to cones, they're related to cylinders like pyramids are related to prisms, okay? So remember, if we look at some kind of a pentagonal prism like this one that I'm drawing, or we'll pretend like I'm drawing it well. So I'd have this, and then you'd have the lines like this one. That looks pretty. Something like this. There we go. Something like that, okay? And then if you wanted a pentagonal pyramid, all you do is you put a point right in the middle of that top one, I guess, for us in this one. And then you just draw lines to all the other corners of, or the vertices of the bottom polygon, in this case, pentagon, okay? And then you'd see that you'd have a pyramid. Okay, well, it's the same thing with cones. Again, they're related to cylinders, though, which are kind of like a circular prism. So we'll pretend like that's a three-dimensional circle right there. And so we just kind of duplicate it above, and that becomes a cylinder. That's okay. See if I can clean this up just a little bit. That looks decent. Well, a cone is where we put a point at the middle or the center of that top circle, and then just connect the edges here. Okay. So this becomes a cone, like this. Right? And yeah, we can clean this up just a little bit more. Maybe. Something like this. Okay? So there is a cone, or we'll pretend like I drew a cone. Right? Now the circle is a circle, and that's nice because we've already dealt a lot with circles. But in this cone, if we took a closer look here, in this cone, it still has a center, just like we've seen before, right in the middle of that circle, and we'll pretend like that's the middle. That is still the center, right there, okay? And then the radius is still the radius. So that's the center to the edge of the circle. Any edge, by the way. That is the radius. Which we need to know because in the formula, the radius is still the radius, okay? And yeah, we see a power of 2 on this. And yeah, we've seen pi as well. Pi is just a constant value. And for the most part, we're going to be using the calculator button for pi instead of 3.14. It's just a little less button pressing, although we do have to round. But then what we have in the formula is this L business right here. I'll make that a cursive L. Which generally L stands for length when we look at shapes like this. But in this case, that L actually stands for what we call slant height. Okay. Well, the slant height is the length from the edge of the circle of the base of the cone to the very tip of the cone right here. So this length right here is the slant height. Okay? Slanted, of course, because it's a cone. It's not really the height of the cone. The height of the cone, which will come later, would have been this length right here. Okay? Or would have been the height of the cylinder, which is more used for volume than it is for surface area. Okay? But if we take that slant height and multiply it by the radius in pi, then this would be the, the cone part. Maybe that's redundant. The cone part of the cone. It's the slanted portion of the cone. And then, of course, at the bottom, or the base, which is pi r squared, pi times radius, that's the actual circle part. Okay. So this brings us to what a net should look like for a cone as well, okay? So just looking at the slanted portion of it first, it will be a circle, which is good to know, which we'll make in green, like this. But what happens is you have, since we want to make a cone, of course, again, this would be flat. But what we're going to do is we're going to find the center of that circle, and you just kind of cut, and you could do this at home if you wanted to. We're not going to do it today. But if you just cut out like a little slice of that, then this part, of course, goes away. This part right here. And then this would be just the slanted portion of the cone. So, of course, the net would indicate that then you would have another circle somewhere attached to this cone, right? Somewhere right there. Not that it really matters where. It could be there, it could be over here somewhere, or over there. It could even be on the edge of that part right there. But what happens is, as you push these two sides together, you'll see that this circle then becomes three-dimensional, and then it will create a cone. And the bigger that you make this slice, the more slanted the cone will be. So the thinner this slice is, the more flat or shallow the cone will be. It doesn't have to make a lot of sense. Again, you can kind of mess with that stuff at home if you'd like. But of course, depending on how big you slice this will depend on how big the circle is as well. But this gives us a surface area, this formula. We're just going to be using this formula straight today in finding the surface area of the cone. Pi times radius times the slant height plus pi times radius times radius. As long as I have my... All right, here's our first example. Take 1 minute and try this one out, then we'll go over it. Okay, 1 minute, go. Find the lateral and total surface area of the cone. Okay, no problem. So let's find the formula first. I'm going to write the formula out here. Pi times the radius. I guess we'll use purple. Try to make it consistent there. Times L, that's the slant height. And then we're going to add pi times the radius. And again, you can do radius times radius if you'd like, or you can do radius to the power of 2, like it showed in the formula. But I am going to show radius times radius. Now, in this problem, they gave us a diameter because it showed the full length of that circle there at the bottom. But I don't want diameter. There's no diameter in the formula that we have, although you could if you'd like. So what I need then is the radius. So I take the diameter and I cut it in half. Okay, that is the radius. That would be 18 divided by 2, which is 9. In this case, 9 miles. So I take my radius and I replace it with 9 in the formula. And again, after we get all these values, you're just going to put this into the calculator, by the way. So it's going to be pi times 9 times the slant height plus pi times 9 times 9. And the slant height on this one was given here at 20.1 miles. They probably should have indicated that it's this slant height right here, but it doesn't matter which side it's on. Still 20.1, so I'm going to replace that L, which is slant height, with 20.1 right there. Okay, 20.1. Now you can do this part by part in the calculator, but I'm not going to. I'm just going to type it completely into my calculator. Pi, and I am using the pi button. Remember, that's the fourth button down from the top left, times 9 times 20.1 plus pi times 9 times 9. And when I push enter, it tells me that the final answer here for the total surface area of this cone is 822.783116. I will round this to the nearest hundredth. It didn't really say where we should have rounded, but 0.78. And again, we are dealing with a surface area on this one, so it is in miles, but now it's square miles. And yeah, oh, and it did ask for that. I completely missed that part. It does want the lateral area on this as well. In fact, we'll make it orange instead. The lateral area is this portion of the formula. Pi times radius times length. So, then in order to find the lateral area, I would take pi, which is just pi, times the radius, which we know is 9, and multiply by the slant height, which we see is 20.1. And again, I'm just going to type this directly into the calculator. Pi times 9 times 20.1. And I get the lateral area of 568.314111. So again, I'm going to round to the nearest hundredth, 0.31 there. And again, we need to label this in square miles. There we go. All right, here's this example. Take 1 minute and try this one out too. 1 minute, go. Nothing's going to really change on any of these problems, really. They should give us the slant height and the radius, or the diameter like they did on that last problem. Of course, on this one, they gave us the radius. So let's look at the formula once again, right? We got pi times the radius times the slant height. And again, that would be the lateral area. The full formula, though, would add pi, and then times the radius times the radius. Okay? So this time, I'm going to do it in order because I actually read it this time, but my lateral surface area, I'll do it a little bit lower, Lateral area is just the first part, or the first term in that formula, which is pi times the radius. And yes, we do see the radius right here at 2 meters. So I replaced the radius with 2. And my slant height was given at 6.3 right there, 6.3 meters. So my total lateral area, again, I'm just typing this into the calculator, pi times 2 times 6.3. I put 66.3, but here we go, 6.3 gives me 39.584, so I'm going to round to the nearest hundredth, 0.58. And our units for this one is in meters, but again, it's area, so we're looking at square meters. All right, and that would be the first answer that we would want on this one. Looks like the homework wants these rounded to the nearest tenth, but I'll do that starting on the next problem. So I got this part of the equation right here, pi r times the slant height at 39.58. I mean, you can round it however you would like, but let's go ahead and add the rest of this. So plus pi times the radius, which again we see is 2 meters, times the radius at 2 meters. So 39.58 plus pi times 2 times 2, and this is the total surface area, which I get at 52.146, so I'm going to round that up in the hundredths place to 1.5. And again, this is still in square meters. So this is the total surface area of the cone, and in orange we have the lateral surface area of the cone. All right, here's this example. 1 minute, go. Try it out. 1 minute. You see that these types of problems where we have a formula is really just evaluating expressions, which I think we did in Unit 3, what was it, Lesson 2, which was part of the Solving Equations unit. So as long as you have the formula, well, you should be able to do any of these problems. And yeah, we do have a poster with that formula as well. So I'm going to start with the lateral area on this one as well, because it does ask for it right there. So that's pi times radius times the slant height, which they use L. And yeah, the order of these doesn't matter. You could do pi times L times R if you'd like. Doesn't matter. But I do see that the L there, the slant height, was given at 26.8 meters. And the radius, well, they gave us a diameter actually, which is 24 meters. So the radius is just going to be half that. 24 divided by 2 is 12 meters. So that's our radius right there at 12. So I replace the radius with 12 in my formula. And then I just plug this into the calculator to solve it. So let's see what the calculator gives us. Pi times 12 times 12, 26.8 rather. And this one I will round to the nearest tenth because that's what the assignment wants. So let's see, I kind of feel like I typed that in wrong, but I double checked and it looks like it's good. So that's 1010.336, and again, I'm just rounding to the nearest tenth. So 0.3, and again, we are looking at square meters on this one. So there's our first answer for lateral area. But we do need the total surface area. And yeah, we're just going to use the formula again. So that's pi times the radius times the slant height, L. And yes, we do have that value, but I'm still going to write the formula out. So pi times, and then add pi times the radius times the radius. Okay? So yeah, we do have this first part right here in the the lateral area. And yeah, that's actually what I'm going to do. I'm just going to, instead of actually rewriting this first part out, that is the lateral area. And we already know what that is in orange there. That's 1010.3 square meters. But I do still have to add pi times the radius times the radius. And the radius they didn't give us, but we found is 12. So times 12 times 12. So I'm just going to plug this directly into the calculator, which will tell me the full surface area of this cone. 1010.3 plus pi times 12 times 12. And I get 1,462 I got 689, so I'm going to round that to 7 right there. But again, we got square meters on that. So LA, the lateral area, 1,010.3 square meters. And in green, the total surface area is 1,462.7 square meters. All right, and here's our last example. Take 1 minute, try this one out. Go. Now I know the homework doesn't, or the classwork worksheet today doesn't show any of these examples. Yeah, it was a different classwork that was printed, but I still wanted you to have some paper to do this on, okay? So even though we're not following the classwork, this is pretty much all you're going to be doing on the assignment either way, no matter if we did what the original classwork did or this. But I think this is more straightforward. Yeah, this is super fun. I understand, like it's really exciting. Between this or sports or movies, probably this, right? Well, let's do lateral area first. So pi, I know you guys are getting sick of this garbage, but I'm just emphasizing it's the same thing no matter what if you're looking for the surface area of a cone. We got pi times radius times the slant height. And yes, this one gave us the radius directly at 1 inch. So I just replaced the radius with 1. And then the slant height there, 4.1 inches. So there we go. I replace this garbage with 4.1. And yeah, just plug this into the calculator. Again, I'm just typing it in directly. Pi times 1 times 4.1. And rounding to the nearest tenth, I got 12.88052988. So 12.88 would be 12.9. And this is in inches, so we'll make this in square inches for our label. That's our lateral surface area. So again, just considering the full formula for this, not that, we really need the full thing because we just found the lateral area. But this is what it looks like. Okay, R is the radius, L there is the slant height. But yeah, we just figured out this part. That's the lateral area at, I'm going to say 12.9. But I still need to add pi times the radius, which was given as 1, times the radius of 1. Okay, so 12.9 plus pi times 1 times 1. And this gives me the total surface area of 16.04159265. So I'm just going to make that 16.0. In fact, you can just make it an even 16 if you'd like. It shouldn't matter. But yes, this is in square inches still. There it is, bam. The surface area of a cone. And yeah, that first part is the lateral surface area. That's good stuff.